I'm Nick Schrock. I'm the founder and CTO of Dagster. And today I'll be talking about this movement we're seeing in the industry and the Dagster community. It's really the rise of data platform engineers and data platform engineering as a craft. These are the engineers that are building unified, centralized data platforms that serve entire organizations and all the stakeholders in those organizations. And the way that we think about it is that, every modern organization has a data platform, and it's just a question of whether it's explicitly and intentionally acknowledged or not. These implicit data platforms, where there's technology spread across an organization, are kind of a nightmare. But if you centralize the data platform and treat it with care, it becomes an essential asset at an organization. So, I'm the founder of Dagster, so I have to talk about Dagster. And we really are designing Dagster as a unified control plane for the data platform. And we're going to talk about this by breaking up this statement into its component parts. So let's start with this phrase, data platform. Many in the industry refer to companies and products like Snowflake and Databricks or BigQuery and other processing systems as data platforms. We think about the term differently. In our mind, we believe that every company has a data platform, and it's all the production pipelines that produce all the data assets that drive your business. And that's what's managed by this platform. Heterogeneity, especially at the enterprise, is the norm here. Many tools, many sources of data, many storage engines, many personas, many use cases. And, we kind of, the way that we think about this is a few different properties of the data platform. So one, the data platform is context specific, right? Every data has its unique needs. Every business has its own history of technology and business choices. Every business has a unique combination of production apps, SaaS apps, internal tools, and use cases. And you must build the right data platform for your organization. Data platforms also model the entire domain of your business and the external world that it interacts with. This is a complicated, demanding world. And without proper care and forethought, it can be the source of a ton of toil. As a result, it's a massive focus of investment, both in time, money, and energy, right? These are CFO level decisions around staffing and money and tools. And lastly, it's worth the investment, not just because it's hard, but because it's foundational. The data platforms and their constituent pipelines and assets drive essential functions in your business, from operations to data-informed decision-making to ML and AI applications. And its value and importance is only increasing over time. So, this leads to Dagster. And, for years, our mission has been to empower every organization to build a productive and scalable data platform. And we think that mission has only grown in relevance and salience over time. More of the world is becoming data-driven. AI is all the rage, and the base foundation of an AI strategy is your data strategy. We also see more and more organizations thinking in terms of data platforms. It's a growing recognition that it's a strategic asset in the industry. Historically, this has often happened in a bottoms-up fashion, with data engineers and data scientists shifting their focus to platform engineering just simply out of sheer necessity, because all the complexity and time was actually spent in the data pipelines leading to machine learning, for example. But now we're seeing the emergence of formal job titles and organization structures that use this term directly, such as data platform engineering, data platform teams. And we think this is a welcome development, and teams which take this approach, we're seeing achieve great success, both for themselves and for their organizations. And really our goal is to make Dagster the natural tool of choice for this next generation of data platform teams who need to provide a unified development workflow, orchestration, and observability across the entire organization's data platform. Let's move on to the next component of this phrase, maybe my favorite part of this, which is control plane. So why is this my favorite part of it? Well, lots of companies talk about control planes in lots of domains. And it's worth asking the question, what does it even mean, right? Very few people actually define it, the sort of nebulous term out in space. And, it really is generally, it when you see it type of phenomenon. So it's worth examining the lineage of this term. It comes from software-defined networking, which emerged in the 2000s and 2010s as the way to manage networks and organizations. So instead of IT having to deal with physical underlying infrastructure to operate and configure networks, they instead managed a software representation of that network, and those devices were controlled via APIs. And this led to much more efficient and flexible network management by smaller, higher leverage teams. So this is the age of AI, as I mentioned. And so in the process of researching this talk, I actually asked various AI services what the term control plane means. LLMs are a lossy compression of all human knowledge. So while imperfect, it's also a good way to summarize commonly understood definitions of terms. So two statements stood out to me here. One is responsible for making decisions about how to handle data or resources. And two, in modern network architectures like software-defined networking, the control plane is often decoupled from hardware and centralized, allowing for more flexible and programmable network management. Well, how would you adapt those sentences to a data platform context? Well, one, making decisions in computing systems is often referred to as orchestration. So just replace the term with it is responsible for orchestrating data or resources. You actually have to have active control over the resources. You can't just do post hoc observation. And then the second sentence, in modern data platforms, the control plane is often decoupled from data processing and centralized, allowing for more flexible, programmable data management. So this is starting to sound pretty familiar here. So let's go through these kind of subcomponents here. One, it's an orchestrator, right? It makes runtimes decision. It's programmable. It's flexible enough to handle any set of tools and any infrastructure topology, and it can be centralized and managed by a single highly leveraged team. Let's talk about the orchestrator. So in a data platform, the orchestrator takes responsibility for runtime decisions about when to run computations and in what order and with what configuration. That is the function of orchestration, and it is at the core of the control plane. Dagster takes this further with asset-oriented orchestration. The job of a data platform is to produce and manage the data assets used by the organization for operations analytics and AI. And we believe it's important for this core abstraction to reflect the core purpose of the platform and to use that vocabulary and mental model that all stakeholders use when interacting with it. That is why Dagster is centered on the software-defined asset, which defines an asset in software that should exist. And then this abstraction makes Dagster a much better and natural user experience, but also a reliable system of record for the structure of the data platform itself. It just makes it a vastly more powerful tool. So let's dig into the second kind of pillar out of the four, which is flexible and programmable. Dagster is this control layer that contains both software definitions of the assets, and by assets, I mean table, machine learning model, report, and it also is an orchestration that takes responsibility for the scheduling and production of those assets. This control layer, is programmable, accessible, and operable via open APIs and built-in tools. Dagster has built-in lineage, cataloging, operational tools that are built on these open APIs, but it also allows customers and ecosystem partners to build their own custom tools and integrations on top of Dagster. And then lastly, this control layer lies atop the data processing layer. And critically, Dagster is able to ingest all the definitions and metadata within those constituent tools, such as models and transformation tools like dbt and SDF, or sources and ELT tools like Sling or Fivetran. And it understands those natively and are able to surface it in a common lineage graph. And then it can invoke those computations that back those assets and ingest runtime metadata so you can keep track of properties of those over time. This metadata layer is like essential to a data platform. So we believe that is critical for that the control plane to integrate with any processing tool or pipelining tool. You might ask why? Well, data platforms are diverse, brings together many practitioners from many backgrounds, data engineers, analytics engineers, ML engineers, data scientists, just to name a few. And they are not going to consolidate on a single pipelining or transformation tool or programming language. Their needs are just too different. And therefore, you must support any tool so that it can be used by any practitioner, right? You want to have a unified experience and a unified platform for all the practitioners in your organization. But it's not just about practitioners and tools. The data organizations, the data needs of organizations vary considerably based on their business context. Organizations come with history, baggage, technical debt, and it's a landscape of heterogeneous data and infrastructure technologies is the norm, not the exception. So it's critical that a unified control plane must be able to deploy flexibly over any existing infrastructure topology. Okay, so only with the right abstractions, programmability, and flexibility comes the opportunity to build this centralized control plane. And they're all three necessary for a specific reason. One, without the right abstractions, you don't get enough richness and value out of the system, and value provided both to users and more broadly the application layer, all the tools you can build on top of the platform. Without sufficient programmability, you cannot manage the complexity of the data platform that you're managing. And without flexibility, you cannot cover all the use cases and contexts. It can't just be one specific pipelining tool or one specific programming language. And it is this centralization of the control plane that gives the data platform team leverage and the ability to provide a compelling unified experience for everyone operating within the platform. Okay, and this naturally leads to our final pillar here, which is unification. And this is not just about technology. This is about the way we organize our teams and our work. So let's start with goals. Like how do we want this data platform to operate organizationally? So let's start with data practitioners. We want them to work autonomously. And that means they are able to focus on business logic and the tool of their choice, onboarding onto Dagster with minimal effort. We want them to be able to self-serve their data pipelines within a software development lifecycle, an SDLC, being able to detect errors, fix bugs, and ship code quickly to resolve issues. This is huge as practitioner teams are able to work independently, and it simultaneously keeps the data platform team out of the critical path so they can work on compounding infrastructure. And finally, we want the data practitioners to work hand in hand as close as possible to their business stakeholders. And platform thinking allows you to kind of deploy these practitioners across the organization without centralizing them all in one team. The flip side of this coin is that we want the data platform team to operate in a leveraged fashion. That means they can ensure that practitioners are self-sufficient and productive by developing a high-quality developer experience and abstracting away all infrastructure concerns. They're able to focus on high-impact platform-wide investments to smooth data operations, improve efficiency, and deliver organization-wide impact. And they can partner with cross-cutting teams like finance and compliance to effectively drive projects of organizational scope. Instead of finance having to pin down every single individual piece of data infrastructure and data team, they kind of have one team to talk to. They can apply policy and reduce costs simultaneously across the entire org. Makes life better for everyone. So why is this not happening now with existing technologies and practices? So let's talk about how this actually plays out in practice. So let's imagine you start with a legacy orchestrator, in this case Airflow, but the same lesson applies to others. And you start to set things up and you have simple pipelines running daily and everything seems to be going fine. But as time goes on, you notice something going wrong. The practitioners are becoming less productive and self-sufficient, and the platform engineers are getting bogged down in just keeping the infrastructure alive. And why is that? It's because these tools were typically not designed with the sort of platform thinking in mind. In Airflow's case, here's a few of the feature gaps that cause this. So there's no multi-tenancy in Airflow naturally. And that means as you onboard more practitioners, they are more likely to stomp on each other, to install conflicting dependencies, and to break one another. There's very little thought given to testability, and a full developer lifecycle just wasn't designed with that in mind. And there's no built-in rich asset-oriented tooling, which generally means a very poor fractured debugging experience and no notion of cross-technology lineage. And that's just a taste of the problem. The net results should sound familiar as both the practitioners and the platform engineers fear to change things and are constantly firefighting. So this inflexible monolith, Airflow monolith, is no longer sustainable. So now there's typically two choices: break it apart or lock it down. Both of those have nasty trade-offs. So let's explore the break it apart action. Breaking apart means in practice moving ownership of data infrastructure to the data practitioners. The concrete manifestation that we see of this at accounts is that they have numerous orchestration instances and technologies managed by the data practitioner teams themselves. There's a ton of problems with this. There's often not enough platform or infrastructure expertise in the org to execute on this. It's nearly impossible for the centralized data platform team to deliver cross-cutting value to practitioners in the form of productivity or tooling improvements. And it leads to the siloing of the data teams themselves. If the ML and data teams use separate orchestration instances, they're much more unlikely to collaborate in practice. And that is a big deal. So, this at least temporarily leads to increased autonomy for the practitioner teams, but the leverage in the platform is very low. It's now extremely difficult for the platform team to efficiently deliver productivity or workflow improvements for every practitioner team. And like I mentioned before, like the finance no longer has the single proverbial throat to choke. They have to chase down every team to set budget, and it's a manual, laborious process that no one wants. So the other option here is to lock down the platform with policy. This centralizes more work on the data platform team and limits and often severely limits the autonomy of practitioner teams. Very concretely, maybe they're not allowed to add or upgrade Python dependencies. Maybe adding a new tool to the stack requires submitting a ticket and a ton of centralized process. And then this almost inevitably leads to data platform teams taking more ownership over pipelines and business logic and debugging and triage. So in this case, the data platform has gained some control and the ability to build centralized tooling, but practitioner autonomy is severely reduced. And this can be frustrating for everyone. Like this dynamic often leads to practitioner teams self-serving their own infrastructure and subverting, bringing in their own tooling and having completely shadow stacks embedded through the organization, which is a bad outcome. So the only way to break this cycle and to have a best of both worlds is to make different organizational and technological choices. And we think having a rich unified control plane like Dagster is the ultimate linchpin technology to successfully executing on this. So this approach and thinking manifests itself in Dagster. Just to name a couple examples here, there's native multi-tenancy, which allows teams to autonomously deploy each other in a guaranteed way without breaking each other. Right? We have a platform-wide notion of branch deployments, which deploys a lightweight staging environment on every PR, and every single practitioner team can utilize that technology, and the platform team can customize the experience. There's super high-quality operational tooling that allows you to see cross-technology lineage and also do event-based scheduling, so you can say kick off an ML job whenever a data job finishes, which is very nice. And then there's this much better asset observability. So we really designed DAX from the ground up with this sort of platform thinking, and it kind of expresses itself throughout the product in many different forms. So that's a technology choice. So how do you match that with an organizational choice? How do you organize your teams and platform in order to execute on this strategy? So this is how we think about it. So there's a single data platform team managing the centralized control plane and a bunch of the infrastructure that it invokes. The data practitioners are their customers, and the data platform team builds a shared platform that unifies DevX, Ops, and observability for all the practitioners. These practitioners and practitioner teams own their data pipelines end-to-end, enabled on that shared platform, allows them to focus on their business logic, work closely with their business stakeholders, within a highly productive software development lifecycle. And then they all build in this common abstraction layer. So they're effectively collectively delivering this unified asset graph, this unified artifact to the entire org, which serves as a system of record for all production metadata. So we're trying to balance both providing a unified experience to all stakeholders, having them be independent, and then having a centralized data platform team that has enormous leverage to deliver a cross-cutting platform efficiently. So we've been using this term, the asset graph. And so what is it? And why do we think it's so important? So it's a graph of your production assets built in any technology by every practitioner in your organization. And people often talk about this in the context of, say, data mesh conversations and other tooling. But rather than an idealized concept, with Dagster, this is an in-product manifestation of the structure of the data platform itself, both technologically and organizationally. And by integrating it with the orchestrator, it's not just an artifact of what happened, but it's a living, breathing system of record for your data platform. And it's a rich substrate where you can directly observe, debug, and operate your entire system. And it's this unified experience collectively built and operated by all the practitioners. So thanks for coming and listening to our vision here. And it centers on the fact that every company has a data platform and they should staff and build around it. We also think it's a great way to build up your career. It's kind of a natural place to go. When a data engineer kind of works on in a data platform context, they're allowed to have more impact, and it's a great opportunity for career growth. And it's also because this is not just a technology, but about the way that the teams work and organize. So, let's just cover the points again. One, it's your data platform. It's a system and tools that produce data. It's a foundational asset, the basis of all decision-making operations in AI. It's costly and a focus of massive investment in time, money, and energy, and it's context-specific to your organization. Like in other domains, data platforms need this control plane. It's the orchestrator, makes scheduling and resourcing decisions, deciding when and what is computed. It's flexible, programmable, able to integrate with any tool used by any practitioner, deployed on any infrastructure, and it's centralized, operable, and managed by a single high-leverage team. And lastly, a unified experience for all practitioners with a unified development and deployment experience, powerful operational tools, and a unified asset graph that serves as a living, breathing system of record. So in the end, what we want is autonomous data practitioners that have end-to-end ownership over their data pipelines, working directly with business stakeholders, enabled by this single high leverage team. And with that, I will end my presentation.